Hello, everyone. Thank you so much for tuning in. Today's topic is a great one and related to data modeling in Microsoft Power BI. My name is Natalie Trudell. I am the marketing manager at CR Group, a acquisitive company, and we are very excited to share this session with you today. Whether you are new to Power BI or you're an expert, you're going to walk away with something great from today's presentation. And leading this session is Power BI expert and BI solution specialist, Saurabh Dasgupta. We are thrilled to have him here with us. And just a quick note for those who don't know who we are, CR Group has been around for almost 33 years. As you know, we have a wide range of experts to help businesses completely transform how they operate. We are a partner of leading business systems like Microsoft, Board, BI4 Dynamics, and Workday, and we really do help to transform the end-to-end digital process and journey in cloud enablement. And that is across ERP, collaboration, business intelligence and reporting, human resources, budgeting and corporate performance management, and of course, enterprise consulting. So we know that businesses do not exist in silos and that all aspects of the company have to be integrated and streamlined in order to meet not only the challenges of today's modern digital work, but to ensure that leaders and decision makers have united data that they need for insight and decision making. So if you would like to learn more about any of these other solutions, please get in touch. And with that, I am going to hand things over to our expert, Saurabh, so we can get started.
All right. Thank you very much, Natalie, for this wonderful introduction. So a very good morning to all of you. Good morning, good afternoon, good evening, wherever you're joining from. So my name is Saurabh, and I'm going to be talking about data models in Power BI today. So, I know a lot of people who are joining the webinar today might not have used Power BI before. So I thought, before we start, I'll just give you a quick overview of the Power BI architecture. So we will see what different products we have. And we know the context and we understand, where exactly this data model fits in the entire product framework. Okay. And obviously, then we'll discuss about what exactly is a data model in Power BI. And before we start creating models, some concepts to understand. So we will talk about fact tables, dimension tables. We'll also understand what type of schemas are available in Power BI data modeling, right? And then we'll see in Power BI how to create relations, how to create models. And we'll then also talk about some important parameters like when you define relationships, what are the cardinalities, okay? What is the meaning of cross-filter directions, how it's going to be useful, what is the importance of these in defining data models in Power BI, okay? And then quickly, I will be talking about one interesting role-playing dimension, meaning this is little different than the usual dimensions we create in the models, okay? I'll explain this with a couple of examples. And then at the end, we'll talk about whether we really need a data model in Power BI. Why can't we just simply get on with a single table and create our reports? Why exactly we need a data model? We'll understand the pros and cons of all different methods. All right. So to begin with, let's quickly take a look at the architecture. All right. There is a Power BI desktop application, okay, which is a thick client application. The data analysts are going to be installing this tool on their machines, on their laptops, PCs, okay? And this tool connects to your data sources, and then you create reports in this particular tool. Now, the connection from the Power BI desktop to the data sources can happen either in the direct query mode, which means from Power BI desktop, the communication to the data sources happen directly. Okay, there's nothing in between. We don't create any intermediate data layer. Alternatively, you can import the data from the data sources and save it in the Power BI's proprietary database engine called as Vertipack. Okay. Now, irrespective of how you are connecting to the data sources, it may happen that your data is not ready for analysis. You might have to do some data transformation, data cleaning. So Power BI gives you another component which is called as Power Query. Now, this is not a standalone tool. This is basically a component within a Power BI desktop model, right? So this Power Query allows you to do some data transformation, cleaning, reshaping, right? And once you're done with that, you're going to create reports within Power BI desktop. Once you create the reports, once you have the data sources or data sets ready, like clean, prepared by the Power Query, the next step is you are going to be publishing all these artifacts onto a different platform, which is called as Power BI Service. Now, this is a SaaS-based web application, web-based application. This is currently hosted on Azure, okay? And this is where you are going to be publishing all your reports and data sources. Power BI service also has a capability to connect, go back and connect to your original data sources for your data to be refreshing, right? And then your end users are going to be using their mobile devices, they can use any browsers to access this particular web-based application, and then obviously they need to provide their credentials, and once they do that, they will be able to access the dashboards and the reports which are created for them. They will be able to consume them. They will be able to collaborate with other users. They can create, like they can create additional reports on the server. They can do ad hoc analysis and whatnot, right? So this is an a regular flow, okay, a regular flow from Power BI desktop to Power BI service. However, sometimes you may say, hey, you know what, I'm not ready to be sending data on cloud. Don't you have an alternative? So Power BI has another alternative where you can publish your work on an on-premise server, okay, which is also a web-based application that's called as report server. Now, this is designed using the Microsoft reporting services engine, but this is actually a subset of the Power BI service. I mean, it has limitations and it cannot do everything that a Power BI service can do, okay? And there are some licensing implications also. And the Power BI desktop application that I will be using regularly will not be used in that case. So you'll have to download a different version of the Power BI desktop, then create reports, then publish it onto the report server, and only then your end users can start consuming it, okay? So this is a natural, that's overview of what different Power BI products. And today we are going to be focusing only on the data model side, okay? That is going to be available within the Power BI desktop application. So before you start creating reports, before you start publishing, we need to know what data models are. All right. So let's start with what data models are. Now, if you remember, like in Power BI, whenever you connect to different data sources, right? Now, what you see on the screen is I have connected to 3 different tables. Okay. Now, one of the tables is coming from SQL Server. One of the tables, or I can also call it a query in Power BI, right? I mean, the query is uh, you can call it a query or a table, and one of the tables can be coming from a CSV. The other one can be coming from an Excel file. So it doesn't matter where you're connecting to. When I connect, Power BI imports or Power BI does a connection to these different tables, and that creates a data set. Now in Power BI, a data set is nothing but a list of all my tables or list of all my queries, right? It's just a list of tables. But if you look at this example, if I have to start making sense, if I have to start creating meaningful reports, like for example, I want to show which are my top product group, which are my top product type in terms of my sales, I cannot I cannot do it without relating the tables to each other. Okay, the sales is in a different table, the product type is in a different table. So if you have to start making sense of these 3 tables, you have to start building relationships, right? When I start relate tables to each other, only then I can create meaningful reports out of it, right? So when we say we create relationships within a data set, we are saying we are creating data models, right? It is basically a conceptual stuff. I mean, we are not really creating any we are not doing a join and creating a data and saving it somewhere. It's just a definition over here. So whenever you will be creating reports, depending upon that, Power BI will start fetching different fields based on the relationships I'm maintaining here, right? This is a very important step, because if you don't do it correctly, your reports will not make sense. All right. And you may also say, why can't we call this as a data model? Because I have 3 tables and I think these tables are not related to each other. So why can't we call it as a data model? I don't want to create relationships. It's perfectly okay. You can still call it data model, but a data model with 3 different tables, very rare situation, right? In most of the cases, we say when you have a relationship created, only then that is a real data model you're creating in Power BI dataset, right? So don't get confused with the terminologies. A data set is just a list of tables. Data model is when you create relationships between those tables or queries. All right. Okay. So let's move on. Before we start creating data models, there are certain terminologies to understand, certain concepts to understand. You don't have to really become masters of all these things, but you need to know what these fact tables are, what dimension tables are. Okay. Let me give you an example. So I'm going to open an existing Power BI file. Okay. Now on the screen, what you see is I have connected to 3 different tables. Okay. Do not worry about these relationships which I have created. But what I wanted to explain you that these 3 tables are of different types. Meaning, if you look at the sales table, that's where I have my sales, I have my profit, my quantity, discounts, right? So this table contains the values which I want to measure, the values which I want to analyze, right? This table contains the KPIs related to my business process. So if I'm talking about sales, my sales information, my quantity information is in this table, right? So this table contains all the facts that I want to analyze, and that's the reason we call these table as a fact table. Okay, because it contains my facts, the transaction. If I'm talking about inventory as an example, so maybe stock in hand would be one of the KPIs that I would like to analyze. So wherever that stock in hand information is, that table will be called as a fact table, right? And if you see the other tables on the left hand side, they are simply an extension to my fact table, meaning I have a product code in my fact table, but I want to know what exactly is this product about. I mean, what is the type of the product? What is the group of the product? What is the hierarchy, right? Where does it belong to? So when I have additional information about something from the fact table, okay, that table here is called as a dimension table. Customer master is also dimension table because here for every customer code, I have an additional information, which is the name over here. Okay, so in short, what you need to know is any table which contains your measurable values, the values which you can aggregate and analyze are fact tables, and all the tables which contains additional information about your fact is called dimension table. Okay, so whatever you do in Power BI, if you go to any documentation, you need to know what fact and dimensions are so that you will be able to relate it much better way, right? Okay, so let me go back to my PowerPoint. So in short, fact tables are also called as truth tables. Dimension tables are also called as lookup tables because we are going to look up values for each product code as an example into the dimension table related to the fact, right? So that's the reason we can also call them truth and lookup tables. Typically, your fact table will have more records because it's like you are recording transactions. So your sales transactions will happen every hour or every day, right? So your number of records will keep on increasing in the fact table. You may not add many columns because the columns would be fixed. Like if you want to, if you're analyzing sales, discount, profit, then that won't change much over the time. But in the dimension tables, it will have unique values, right? I just need to have my unique names of products. Now, unless you are adding products every hour, your dimension table will not grow so rapidly. The number of rows will not increase. You may add number of columns because, for example, right now I only have product name and description. Maybe I'll add a product type later on. I may add a product subtype later on. So your dimension table may grow horizontally, but your fact tables will grow typically vertically. Okay, so that's a distinguisher so that you know what is my fact, what is my dimension table. All right. Another thing that we need to understand is schemas. Okay, you might have heard about this term schemas. And before I start showing you what schemas are, please note that you don't have to become masters of schemas. Okay, I'm just giving you some examples so that you understand what schemas are and how do you distinguish between them. There's one schema which is called a star schema. What exactly is this? Now you know what is a dimension table, what is a fact table, right? So in this example, you can see there is one single fact table, okay, which is the sales orders. I have the sales information here. And then for each one, like each individual, for example, I have customer codes here, I have product codes here. For each one of them, I have a separate dimension table. How do I know this is a star schema? Not because the way it looks like, because each dimension table is related to the single fact table. If you notice, none of the dimensions are linked to any other dimension. They are directly connected to the fact table. If this is how your relationships are, that means it's a star schema. Okay. Now, this is the best recommended option. We say that if you have a star schema, it's going to be performing better. Okay. It's widely used in all data warehousing and any data modeling that you will be doing. Right. Now, there is another schema. Okay. One more thing, you don't have to really organize your tables like that. Okay, it may happen that your fact table could be somewhere in the top and your dimension tables are at the bottom. Okay, the fact table could be at the left hand side, all the dimensions could be on the right hand side. So the layout is not important. What is important is these connections. Okay, each dimension needs to connect to that single fact table, and only then it becomes a star schema. Okay, uh, the next one is called snowflake schema. This is just an extension to the star schema, meaning if you see here, that dimension table users is not directly linked to the fact table. Okay, it is linked to another dimension table. Okay, and it is indirectly connected to the fact table. So if you have a scenario like this, we call it as a snowflake. Okay, generally we do it because we may not want to have repeated rows. For example, in the region table, one region may have multiple users, so I may not want to repeat the region values in that table. So I want to keep it separate. I want to normalize the data, right? So that's the reason I may want to keep it like this. And the moment I do that, it becomes a snowflake schema, right? And then the third one is it's it's also called as a fact constellation or a galaxy schema, where you have multiple fact tables. When you have multiple fact tables, a single dimension is linked to all the fact tables. See, the customer is linked to both the fact tables, and the region is also, right? So when you have an overlapping of multiple star schemas or multiple snowflake schemas, we call it as a constellation schema. Okay, I'm again saying that you don't have to become masters of this. Okay, this is just a concept that you need to remember in brain. So whenever you're creating model in Power BI, you actually know, you can explain others what you are doing, right? Okay, so now let's go and create some relationships. So how do we do that in Power BI? Let me show you. So this, what you see on the screen is also very important. Let me explain you this with an example. So let me just open a Power BI file. Okay, I'm going to click on the file button, and I'm going to go to the options and settings, and I'm going to click on the options. Okay, there will be many options, many configurations that you can do. Okay, like there are global configurations which will be applicable to the entire Power BI, all the Power BI files on my machine. However, I just want to go to this current file, meaning I want to do some configuration only for this particular file and see these options. Okay, by default, the first and third one are selected, and this is very important, and I really like this. The first one means, let's assume that I have an SQL Server database where I have some tables, and I have already created the relationships in my SQL Server, meaning I have defined the primary keys, I've defined the foreign keys, I have created those relationships in the SQL Server already, right? Now I want to connect to those tables in Power BI. So why do I need to again create those data model, again create those relationships? Because selecting that first option, I can tell Power BI to inherit all the relationship information from the database and do it for me in the Power BI. Okay, the first option will automatically create the relationships for you, and I always select that because this is a very useful information, right? Now, let's say your database is not configured for relationships. You have never defined relationships in your database. Okay, then the third option will be handy, because now if the moment I will connect to all the tables, Power BI will apply some intelligence by maybe looking at the column names, the types, the data, and it will try to create the relationships in the Power BI desktop by itself. Okay. Now I've seen a lot of people don't select this because they say, hey, Power BI may not do it correctly, so I would like to do it myself. But I don't see there is a harm, because let Power BI suggest me, let Power BI recommend, and then I may go and change those recommendations, right? So I always keep the first one and second one selected. The third one, the second one is a little tricky, because assume that in the SQL Server you have relationships. I import that into my Power BI model. The relationships are created. Let's say I go there and do some changes. I create some reports. At a later stage, somebody goes to the database and make changes in the database relationships for whatever reasons, right? Now, if I come back to Power BI desktop and refresh the data, all your relationships in the Power BI desktop will be overwritten, and the new relationship will be inherited from the database. That is going to be very risky, because all your reports will now start giving you incorrect output, right? So we always keep this unchecked. You will check it only when you think it is required, right? So these options are important. You need to remember this, and I'm going to keep these options as is. Okay, and now let me just connect to, so I have a database in my SQL Server, okay, where I have created some relations. So let's see whether Power BI can import that for me. So I'm going to connect to my SQL Server, and I hope I won't have any problems, and I hope I remember the database name. I think it is Cube. So okay, we'll see. And I hope you remember what is import and direct query, right? Direct query means I'm going to connect directly to the SQL Server. Import would mean import all the data from the tables in Power BI's body back engine. Okay, so at this point in time, I'm just simply going to live like direct query. I don't want to import any data, just to save some time, right? Let's see whether I can connect. So I'm going to click on OK, and So it should now give me a dialog box, and it should show me the list of all the tables in that particular database. See, there are a lot of tables here. Okay, now two things are going to happen here. The first step is, let's say I'm going to click on, say, the order details. That's my fact table. That's where I have maintained my sales and other fact information, right? Now, you see a button at the bottom which says select related tables. If I click on that, Power BI is reading the SQL Server relationships, the primary key, foreign key relations, and it is giving me, it's telling me that, with orders, order details and product tables are linked. They are related. Okay. Now this setting, like this button, has nothing to do with the options which I was showing you. Right. This is different. This is going to be used only when I will be creating data models. Right now, what's happening? It's irrespective of whatever options you select. The moment I click on this button, based on the selected tables here, it will suggest you what are the other tables linked with the selected table. So the moment I click on this, you see the other tables are getting selected. As long as I get this message, it says, okay, we cannot do it further. Like, we didn't find any more related tables. I'm done. And I could have done it manually also, right? But let's say I have a lot of tables. Why do I need to, manually scan through all the tables and do it? So I can click on this button. And once the tables are selected, I'm going to click on load. I will not transform data because the data is already clean. I don't want to go to Power Query, right? I just click on load button, which will connect to those tables, right? It will read the primary key, foreign key relationships. Why? Because the options were selected. And now I'm hoping that a data model would be automatically created for me. And I don't have to do anything manually. All right. Now, this is what happens when you connect to any database, right? You get a blank canvas. So where is my data model? If you see on the left hand side, right now we are in the report view, report mode. This is where you drag and drop and create reports. But if you see, there's another tab here which is called model. That's where I'm going to click, and that is where, let me just make it a little bigger so you can see it. Let me just put it in the entire screen. Yeah, see this, all the tables are connected like here, and you can also see each of the tables have some relations. Okay, do not worry about these icons like stars and arrows. If you can see, all the tables are linked to each other, and this has happened automatically. It has read from the SQL Server, right? So this is one way of defining relationships. I'm trusting what has been done in the database. Another option to create relationships is do it manually, right? Let's focus on, let's say, these two tables. Okay, let me just make it a little bigger so we can see it clearly. Okay, if you see order details and products, let's assume that Power BI could not create this relationship. I'm going to right click on this and say delete the relation. Okay, let's say this relationship is not there. So how would I have created? Now there are two ways of doing it. One option is you click on this manage relationships. I don't prefer this because it's not visual. So here I can see all the existing relations. If you want to add, you'll have to click on the new button. It'll give you a dialog box, and then you have to start from scratch. You have to select the table, then the field, and so on, right? And I don't prefer this option, so I will not spend too much time over here. I'll show you a shortcut. So let me close this. I know that the product ID field here should be linked to the product ID field in this product table, right? And that's how the relationship will take place. I simply need to drag and drop. So you can start dragging from the order table and go to the products, or you can do it vice versa also. You can start from the product ID here and drop it over here. Doesn't matter, right? So let me just start dragging the product ID. I have to be very careful that I have to drop it on the top of the product ID, and then the same dialog box will appear with all the fields selected for me, right? You can see the order detail table on the top. It says the product ID field is selected. Then I have the second table, which is the products. And in that table, I have selected the product ID. So product ID is equal to product ID, right? And the relationship has been established. There are a few more things which you can see at the bottom, like cardinality, then cross filter direction. I'm going to be talking about that in some time. Okay, right now just focus on these two. Okay, you have to be very careful. You can actually go and change it. You can say about order ID is equal to subcategory ID, which is not correct, but you can select different fields from here like this. Okay, just make sure it is correct, and then simply say okay, and you will see the relationship has been established. Okay, so one option, you can rely on the database if it is already there. If it is not there, you can do it manually by dragging and dropping, or going to the manage relationship dialog box and then do it from there. Okay, well, before we move on, there are a few more things we have to understand, like few more concepts we have to understand, right? We just saw that when we were defining relationships, there's something called as cardinality. Why is it here and why is it important for us to know? Okay, there's something like many to one, one to one, what exactly this means. Okay, so we'll understand this now. What is cardinality? It means, unique number of values in a set, unique number of values in a table or in a bucket, right? So when we talk about Power BI data modeling, okay, there is one cardinality type which is called as one to many. Okay, let me explain this to you with an example. If you see this diagram, I have two tables. Okay, product is a dimension table, sales order is a fact table, and I have linked both the tables using product code. Okay, in the product table, because it's a dimension table, the values in the product code are unique, meaning this P001 has a single record in this table. This P001 will never appear in any other record. Okay, so I have one single record for each product. So these values are unique, right? And that is the reason this table becomes one table. Like this is the one side of the table. Okay, we call it one table, right? And it is denoted by either one or you can just say one, right? On the other hand, if you see the sales fact table, it's a fact table, and that is the reason for every product I may have repeated rows, like P001 is sold multiple times, so I have multiple instances of that product over here. So this table becomes many because I have many instances of the single product code, right? And we denote it by a star. So this is a many table, right? So whenever we have a relationship like this, Power BI calls it as a one to many. Okay, at this point in time, do not worry about this arrow. Okay, just ignore that. Okay, only focus on this one and star. Okay, so right now I have a one to many. Now it depends on how you're looking at it. If I look at it from the top to bottom, I will say this is a one to many, right? If I am looking at it from bottom to top, I will say this is many to one. So many to one and one to many are exactly same. It is just that how you are seeing it, how you are visualizing it. Okay, so, and this is like the most recommended type in Power BI. Power BI says if you have one to many relations, your Power BI model or the reports will really perform better. Okay, we should have these kind of relationships. In a star schema, you'll always have one to many. Okay, we'll see some examples. The next one is called one to one. Okay, if you see the example, the table one, I have unique values of each of the projects over here and some attributes. The table two, I have again unique values of each of the projects, like they are not repeating, and I have some attributes. Like ideally I could have combined both the tables into a single table. Okay, I don't really have to have two tables and do a one-to-one relationship like this, but in some scenarios you may have to do this. Okay, so if we have to do this, then this is called as a one-to-one relationship. Why one-to-one? Because of the cardinality of the column that we are using for relationship. Okay, in both the tables they are unique, so this is a one-to-one. Okay, ignore the arrows for timing. It's a one-to-one relationship, and we say try to avoid it, right? And the last one is called many to many. It means if you see the table one, the state California appears twice here. Okay, for whatever reasons, the state California again appears twice here in the second table. And if I relate both the tables, the cardinality becomes many to many. Okay, and this type of cardinality can create a lot of problems in Power BI. So Power BI says ignore it. Microsoft says ignore these kind of relationships as much as possible. Okay, you should try to convert these many to many into like one to one, sorry, one to many, or maybe a different alternative, but try to avoid it as much as possible. Now there are many ways you can avoid it, but let me give a quick example. Okay, so if you see on the left hand side, this is the same many to many. I mean, I'm not saying you cannot do that in Power BI. You can do that. You can still create reports from the left-hand side model, but Power BI has to really do a lot of efforts for generating the queries and processing it. Uh, if I can convert this many to many into something like on the right hand side, where I have created another table only for the states, which has unique values of the state names, and then I have a one to many to both the fact tables, right? This is not a star schema because I have two fact tables and I have joined it with one dimension, so it is actually a galaxy schema. So it doesn't matter what schema it is. What I'm trying to say is that I have converted a many to many relations into one to many. Why? Because I wanted to follow best practices, and Power BI said this is how I'm going to be working better, right? So this is how these are the three different cardinalities: one to many, one to one, many to many. And I'm saying try to avoid many to many and try to convert them into one to many as much as possible, right? Okay, so let me go back to Power BI, and that is where you select it in the drop down, right? Power BI will always identify the correct cardinality the moment you establish a relationship. You don't have to worry about it. Okay. However, for example, if you see, it has automatically selected the many to one because it knows that this is the fact table. So I have many product IDs here. The second one is the one type. So this is many to one, right? I cannot change it to one because the moment I do that, it will give me an error message. It says, you know what, table one has many product IDs. It is not a many one table. You cannot do that. I can also not change it to one to many for the same reasons, right? But I can go and change it to many because I'm saying, you know what, right now I have unique values of the product IDs here, but maybe at a later stage I may have duplicate records for whatever reasons, right? If that is a scenario, you can change it, you can force it to change it over here, right? But I'm going to be going with the Power BI's recommendation right now because I know this is correctly done, right? So you can change this type over here, but in most of the cases it is not required because Power BI will do it for you automatically, right? Now the second thing is, what is this cross filter direction, and is it also important? Okay, can I just go with the default one, and do I really need to go and see what different options are here? So let me explain you this with an example. So let's go back to the PowerPoint, and so on the screen, let's say this is a data model. Okay, I have a sales fact table, I have a year dimension table, I have a product dimension, which is linked to another category dimension. So it's actually a snowflake diagram or schema because this dimension is linked to another dimension, right? Again, doesn't matter what schema it is. Now, the thing is, I am creating a report. Okay, and also notice this one to start. This is a one to many, that's a one to many, that's a one to many relationship. Okay, this arrow is going to play an important role in some time. Okay, I'll explain you what is that. So I'm creating a report where I'm saying I want to find out the sales quantity from this table for a particular category in a particular year. So I want to filter the data for category A and 2018 and then find out what is the total quantity, right? How will Power BI evaluate this? How will Power BI really find out this answer for me? Okay, Power BI will come and say, hey, you want to filter on category. Okay, where is this category in which table? I will say, okay, this is in the category table. So it will first apply a filter on that category table. Okay, filter the data for category A. The moment it does it, the next thing it will do is it will propagate the filter. Okay, it will propagate the filter from this particular table to the next table to which it is linked to. Okay, so because product is linked to the category table, it will propagate to the product table, and from there it will filter all the category A rows. So I will find two product IDs. So ID 1 and ID 3 belong to category A, and that table is filtered. And when this table is filtered, the filter is again propagated to the next table in the path. Okay, in the path I have the sales table, so it will filter out the product ID 1, the product ID 3, and the total quantity would be 11 plus 3, 14, right? But now I have another filter in the question, which is 2018. The Power BI will again go to this dimension and filter for this particular year, and this year filter will be propagating to the next table, which is the sales table. So it will remove the 2017 and only keep the last record. This pertains to category A in 2018, and my answer would be 11, right? So this is how Power BI evaluates any report or any filter. So it always starts from the dimension tables and it filters to the next table, and it goes to the fact table and fetches the appropriate results, right? That is how my evaluation happens. And now you understand what is the meaning of this arrow, right? The arrow means how the filter is going to be propagating, like from which table to which table, right? The arrow is very important here. All right, let me give you another example, explain you with an example. See, I have a sample data model created here. Let me show you what these different tables are. I've got three tables. Okay, so I have a sales table which has my region IDs, and I've got my sales value. So I have region repeated here. For each region, I have multiple transactions, right? Then I have a region dimension table where I have each of the region IDs, and for them, I have the respective names. Simple dimension table, right? I only have the region names here. Then I have another table where I have the region to manager mapping. One region is mapped to multiple managers. So region 1 has 2 managers, region 3 has 2, region 2 only has 1 manager, and 4 has also 2 managers. Okay. Now, when I have created the data model, when I connected to these tables, Power BI did this by default. Okay, I did not do this because Power BI could automatically detect the relationships, and it created this for me. So if I stay with this default recommendation, will I have any problem? Will there be any problem? Because if you see, my relationship is from the region, like 1 to many, and the direction, look at this arrow, it means I will be propagating filters from region to the manager table, not the other way around. And similarly, from region, the filters will be propagating to the sales table, right? What is the problem? So let's see. I'll go to the report view, okay, and I've created 3 different reports here. Okay, look at the first report. Here I have selected 2 fields. The fields are coming from the dimension table and the sales fact table. This is simple. Now the moment I say I want to show sales for each of the regions, what is happening in the background is Power BI goes to the data model, it filters a region name from here, let's say East. The filter propagates to the sales table, it finds out the respective sales of that particular region, and it shows it to me, right? As simple as that, no problem. The filter direction is working for me. Look at the second table. Okay, what's happening here? I have got 3 fields. I have got all the fields from my different tables, the manager, region, and the sales. So I'm looking at East. I see what are the different managers of that particular region and what's the total sales over here. Now because I have 2 managers, the value is repeating, but that's fine. I'm still getting my answer, right? And how this is happening, if I go to the data model, I first go to the region table, right? I go left hand side, the filter propagates to the left hand side. It finds out all the two managers of that region, displays it, and then it propagates to the right hand side, fetches the related sales for that region, and then just repeats it wherever the region name appears, right? So I'm kind of going to the center table, then propagating to the right hand side, going to the left hand side, and bringing the information, right? So far so good, no problems at all. But look at the third table. In this third report, I have got a field from the manager and I want to see how much sales each manager is generating, but now I don't get the correct answer because everywhere I see 9,700. That's the total value. And this is happening because in the relationship, Power BI first goes to the manager, it filters one manager, but then it is unable to travel to the sales table because there is no direct path. Like we don't have a direct relationship to the sales. We also do not have an indirect relationship to the sales. It cannot travel to the sales table, right? And that is the reason there's no mapping happening. Now, what do I do here to solve this problem is I can double click on this relation and I'm saying change the direction of the filter propagation to both, meaning let Power BI travel in both the directions for different scenarios, right? And I'm going to say okay. You will see the arrow will change. It means I can travel in both the directions. Let me now go back and see the report if it has done any changes here. See, the first 2 reports do not change because I was not really worried about it because the filter propagation was already correctly set. But look at the third one. Now I can see the values correctly coming over here. Now why this is happening? Because now I go to the manager table, then the filter propagates to the region, and from the region it goes to the sales table. So the moment I create a path for the filters to travel, my reports are going to make sense. So filter directions are important in a given scenario. Okay, if I had to never create this report, I would have stayed with the single filter direction. Okay, otherwise I would have gone and changed this filter direction to different things, right? uh, let me show you what different types of filter directions you can do. So it depends on the cardinalities you are selecting, right? We have seen the examples of the first one. So if you have a one to many relationship, okay, you can have a single relationship. Now if I have a single relationship, it always travels from one to many. You cannot have it like many to one. That's the rule. Okay, it will always travel from the region table to the sales table, the dimension table to the fact table. Alternatively, we can change it to both, and we just did that, right? And it is also called as bidirectional. If you have a one-to-one cardinality, you cannot do a single, it has to be both. That's the rule. Okay, if you have a many-to-many, then you can have these 3 options. The option number 1 is like the table 1 would be filtering table 2 like in a single way. It cannot come the other way around. Or you can say table 2 will filter table 1, not the other way around. Or you can say it can be bidirectional. All right, now having said that, both filter directions in a relationship model are risky. Okay, they can create problems. They can create performance related issues. Okay, so you should be avoiding it as much as possible. there are different ways to overcome. Like you don't have to go and change it to both in the relationship model. There are different ways you can do it. You can write some DAX calculations, and you can apply in a particular report. You can use, you can force Power BI to have a both directional filter propagation. So there are a lot of ways to do that, but technically you can go to the relationship model and do it. But I'm saying, as a best practice, you can try avoiding it. Okay, it can create some performance related issues at a later stage. Okay, just keep this in mind. All right, so now we have talked about relationships, we have talked about cardinalities, we have talked about the filter directions. When we understand what is the importance of all these things in a relationship, right? Let's see what is next. So whatever you have seen so far, so whatever models I was creating, let me explain this with an example. Okay, so let's say I have this data model here. I have not created the model. You have noticed that whenever I was doing a drag and drop, whenever I was creating a model, I was only selecting one field and just doing a drag and drop like this, right? And it was selecting the cardinalities, and then I was selecting OK. The relationship was established, right? But let's say the logic is different. In this particular example, I'm saying, you know what? The logic to relate the fields is not a single field. So if I have to find out the actual versus target sales, I need to combine the product name and the year, and then link it to the product name and the year. So I need another relationship from year to year, not only product to product. So product to product will not be the correct one. So I am saying, okay, why not we do this? So let's drag year and also drop it on the year. What's the problem, right? Tableau will say, the Power BI will say, oh, see, I can create another relationship with years. Let's say, okay, let's not worry about all the other things. Let's say, okay, relationship established. What is the problem? The problem is, if you see, the first one which I created has a solid line, and this is called as an active relationship. See this, it is already selected here. Okay, the second one which I created is in a dotted line, right? And this is the inactive relation. So what is the problem in Power BI? You can drag as many fields and create multiple relationships, but only one of them can be active at any given point in time. Okay, the other relationships are going to be there, but they are not inactive, meaning whatever reports you're going to be creating they are going to be always using this relationship, not the others that you're selecting, right? So at this point in time, so what is the need of this inactive relationship? Do we really need it? We may need it, so I'm going to be explaining that with another example. But right now I have a different problem to solve. So here I'm saying, how do I make sure that product name and year both become my active relationship, right? I cannot do it this way. Okay, so let me first delete these two relations. Okay, let me just delete it. Let me delete the other one also. If you want to have a combined logic, you'll have to create a combined field or a concatenated field in both the both the tables before you start creating the relationships, right? Now you can do that at the source data, right? You can create the column over there, or you can actually use a DAX formula to create a new column, okay? Or you can actually go to the Power Query to create new columns and come back to the data model and do the relationship, right? I prefer it to be doing it at a Power Query level, because I'm creating a new column which I'm going to be using in a relationship. So I want to do it in a place which is closer to my data sources. This is the first step we do, right? We always do data transformation, so that's the reason I always prefer to do it. You can do it in the DAX calculated column also. There is no problems with that. Okay, I find it comfortable over here, so I'm doing it here. So I come back to the Power Query mode here. I select the actual sales table. I'm going to say click on the year table, select the product name, and then I will click on the add column. I will say merge the two columns together. So I'm actually creating a concatenated column, okay, by year and product. And I'm saying let's have a comma here, okay, and we can give it a name. So I'm saying this is my key for the actual table, right? I mean, it can be any user defined name. This is comma. I save. So I get a new column here, which is the concatenated value, right? Similarly, I go to target sales and I will quickly select the year and the product. I will click on the add column, merge columns, and I have to make sure that I do it exactly same the way I did it for the actuals. And now I will say this is my target key, right? Perfect. So when I save this, a new column gets created. And now I simply have to save this, apply the transformations. So when I apply it, when I go back to the data model, The new column will be appearing here very soon. Okay. And then I simply have to create the relationship using the new column, not the individual product name and the year name. Yeah, now you can see the two columns over here, right? So just drag the key actual and drop it on the key target, and I'm done. And now because these have become the unique values in both the tables, the relationship has become one-to-one, both directions, right? But Power BI automatically detects it. So what I'm trying to say here is, if you have multiple columns in the logic of relationship, create a concatenated column first and then do the relationship like that, right? Okay, now we talked about active and inactive relationships, right? What exactly is the use of that? Why do we really need it? So let me explain you another example. Okay, let's see another scenario. So let's say, see, this is a report. Okay, in the report I am showing a date. So I have a sales table where I have, for each of the orders I'm recording, I have an order date, and I also have a date when this order was shipped to the customer, right? Now in this report, what I'm showing is, if I scroll down a little bit, say for example this one. So on 20th of January, 58 orders were placed, okay, by different customers, and on the same date we shipped 24 different quantities to different customers. Now these two quantities can be from different orders, but I just want to simply display one single date, right? And I want to display the 58. The 58 is number of quantities ordered, and 24 is the number of quantities shipped on the same date. So I don't want to display multiple dates, just one single date and give me the information, right? How do I do that? So if my data model, if I go to the data model, I have a date dimension table. So I have a date and I have some attributes of the date. I have the fact table on the right hand side. And if you see, I have got a relationship which is established from the date field to the order date. And this is a solid line relationship. So this is an active relationship for me, right? So whatever reports I'll be creating by default, it will always pick up this relation. Okay, if I show a date and I show something, that something would be related to the order date, not the ship date, right? But I have a scenario where I have to also show the quantities shipped, right? So what I did was I created another relationship from the date, the same field from the date dimension, but I am relating it to a different field in the sales order file. I'm relating it to a ship date, right? And this has become inactive relationship because I am not going to be using it anywhere in any report by default, right? But if I have done these kind of relationships, I can modify my reports. So here in the report, what I've done is I have used two different columns or two different measures. Okay, let me just make it a little bigger. So if you see here, this quantity sold is the default field coming from my data model, right? This is not a calculated thing I've created. It's coming from my data source. So this quantity sold is the first field. So whatever value you see here, this is related to the order date. So it is actually going to the active relationship and says, oh, where is my 20 January 2018, and find out all the orders which were placed on that date and what is the total quantity. So I get this 58 from there, right? But then I created a new DAX calculation. So people who have not used Power BI before, DAX is a way you can create your new expressions. The way you write expressions in Excel, you can create expressions in Power BI also, and the formula is called as DAX. Okay, so I created a simple formula here, and what I did was I said, you know what, I want to calculate the total quantity, but I don't want to use the active relationship. So I'm using a function here which is called as use relationship, and I'm saying use the relationship from the date field in the date dimension to the ship date in my fact table, not the order date. So I'm forcing Power BI to use a different relationship to calculate this quantity sold, like the same measure in a different relationship. So I'm actually creating a parallel relationship along with the active one, right? And this formula, or this measure, will give me the value of the second column, right? And I can achieve this if I have this inactive relationship created over here, right? So if you have a scenario like this, you can create inactive relations, and then you can create DAX calculations to use these inactive relationships for any particular given scenario, right? And in this particular case, this date dimension is also called as a role playing dimension. Okay, why role playing? Because it's the same dimension playing different roles. It's at one time it is playing a role of the order date, In the second instance, it is playing the role of a ship date. And in the report, I just have one date visible, right? The same date is playing two different roles into different columns. So these kind of dimensions are also called as role-based dimensions, right? Now, there is another example of a role-based dimension. Say I have another example, another scenario. If you see a report here, I'm displaying two filters or two slicers, right? In the first slicer, I'm showing order dates. Second one, I'm showing ship dates, right? I have to display two dates. So I'm saying, show me all the transactions, show me all the orders which were placed in 2019, but we ship them in the next year. So do we have this kind of a combination? So I will select a date in or a year in the order date, another year in ship date, and only then I will be seeing a combination at the bottom. Now I cannot do that in the previous example with inactive relationships, because in there I was only showing one date field, right? But here I have to show two date options. Now if I were to do that, I did a small change in the data model. Okay, let me just show that to you. It's the same data model I was using before. I simply extended it. So I created another dimension table called as ship dates. Now I have different relationships. The left one is to the order date. The right one is to the ship date. So it looks like a regular dimensional model, right? But I'll tell you how I created this ship date, right? This date dimension, let me go to the data tab, right? So if I click on the dates, this is these values are coming from my source file. So wherever I've kept this date dimension, date table, right? However, when I created this third table, I simply created a DAX calculation. I'm saying this is the new table called as ship dates, which is equal to the existing date table. So it's just a reference. Okay, I'm not really creating another file for this. It's just a reference, and automatically a new table will be created, and then I can have a dimension, a relationship to the appropriate field over here, right? And obviously, when you will load the data will be created for both the dimensions. Like the data will be loaded for both the dimensions, it will be duplicated. But for creating it, I simply used a reference formula, right? And here also, because it's the same dimension just appearing twice, we can also call this as a role-playing dimension, because the same dimension is playing two different roles here. And why I am doing this? Because my scenario is different. I wanted to show two different dates. So this date is coming from the first dimension. The second one is coming from the second dimension. And when I select the years, I see the appropriate result in the background, right? So in short, this is what a role-playing dimension is, when you have a single dimension playing different roles. All right, so we have looked at different types of relations, different cardinalities. We have understood what is the meaning of filtered directions and why they're so important in relationships, right? We have seen role-playing dimensions also. Now the question is, do we really need to create data models? Can we not simply create a single table? For example, can I not simply go back to this Power BI model here? I have so many tables here, right? Can I simply not go to SQL Server and write a query or write a view, combine all the tables together, get all the columns in one single flat table, save that table somewhere, and then from Power BI, I simply connect to that particular table? What is the problem, right? Now, the answer is yes, you can do that, and the answer is also no. Okay, so if you have a smaller data set, okay, and if you have less complex scenarios, meaning your reporting requirements are very simple, you just want to do simple drag and drop of the existing fields, you will never be creating complex DAX calculations. If that is what your scenario is, you can obviously go ahead with a single flat table. Okay, you can say, hey, I am not going to be paying the cost of the relationships, obviously, because everything is in one single table. But the moment your number of records will grow, the moment you will have complex DAX calculation, and that's when you will start getting problems in terms of performances. Okay, because the moment you have bigger tables and complex calculation, the entire table needs to be loaded to the memory, entire table needs to be scanned, okay, for every single calculation, and that's where you will start getting problems. So if you have simple scenarios, use the flat tables. But if you have complex scenarios, a dimensional model is always going to serve you better in long term. Okay, and it's the best practice to follow. It also gives you a better understanding, because the moment you will start sharing these data sets to different people, they don't see a list of all the fields. Okay, for example, here, if I go back to my report mode, I can see that if for example I want to drag and drop my product types. I don't have to search through all the table names, right? I know where it belongs to. I can just simply click on the products. I only have 3 fields. I can simply drag and drop and put it over here, right? So it's easier for the users to search your fields. May not be a great factor for deciding models, but yeah, it's one of the factors. And another factor is if you have a proper data model design, the way Power BI application is designed, it is always going to give you better results because the storage is optimized, and the way it processes the queries, the way the filters are propagated, it always gives you better performances in the long term, right? So always follow a data model best practice. With simple scenarios, you can always go ahead with a flat table. So with that, that is all from my side about the data models in today's session. Okay, thank you very much for staying with me. And now I'm going to be passing it over to Natalie. She would like to talk about, another service, another consulting service that CRG offers to clients, which is around the world of dynamics. So over to you, Natalie. Thank you very much.
Thank you so much, Saurabh. That was excellent. Just a great overview of this important concept. Definitely a note for anybody who is using right now Microsoft Dynamics, specifically AX, Nav, 365 F&O, or Business Central. There is a solution that automates the data warehouse process and offers a complete library of plug-and-play Power BI and Excel reports. So of course, that's BI for Dynamics. It facilitates that entire process. So if you are a Dynamics user and would like to fast track your Power BI usage, please visit our website to learn more, sign up for the 30-day free trial, or get in touch with us. Big thank you to Saurabh. This is such a great topic. We are big fans of Power BI. It's a phenomenal solution, but there's certainly a lot of things to navigate. So please get in touch with us if you need assistance with setup, with training, with support, with integration, anything at all. That's what we're here for. Thank you so much, Saurabh.
Thank you. Thank you. Thank you very much. Have a good day. Bye-bye. Take care.